Okay, so today we are going to be talking about derivatives. First up is, what is a derivative? A derivative is defined as the rate of change of a function with respect to the variable. It is usually written as f prime of x or y prime of x, depending on how it's written as a function. Some examples of derivatives. So if we were to take the function x squared and we would put it into the definition of a derivative, which is read as the limit as h approaches 0 of f of x plus h minus f of x over h. If we were to plug in the variables into the equation, you would plug x plus h into the function x squared, and as well as x into the function x squared, and then you would write it into the equation as the limit as h approaches 0 of x plus h squared minus x squared over h. Now, the next step would be that you would have to square out the term x plus h squared, and you will get the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared over h. Now, the 2x squareds, the x squared minus x squared would cancel out, and you would also want to take out an h term from the top, that would be, and then multiply by the inside to get out a common factor of h. And so you would then get the limit as h approaches 0 of h times 2x minus h over h. And as you now can see, both the h on the top and the h on the bottom will cancel out, and you will be left with the limit as h approaches 0 of 2x minus h. Now if you were to put in 0 for h, as the limit says to, you will then be able to find that the limit would then equal 2x, and that would be the derivative. Now another way to solve for the function f squared and find its derivative is by using the function. If the function were to be described as x to the nth power, the derivative would have to be written as n times x to the n minus 1 power. So if we were to take the term x squared, the function f squared, and use this description of a derivative, you would have 2, which is described as n. You would bring down the 2 and then multiply it by x times 2 minus 1. And that would give you 2 times x to the first power, and x to the first is just described as x. So the derivative there would also be 2x. As you can see, they both compare. How does this really tie into physics? Because obviously this is all just calc, and it doesn't really have a tie-in with just that, but really the velocity, it ties into the position, velocity, and acceleration functions, and velocity is described as the rate of change of the position function with respect to time. And so that is p prime of x equals v of x, which is the velocity function. And then in turn, the acceleration is described as the rate of change of the velocity function with respect to time. So v prime of x equals a of x. So the derivative of the velocity function or graph is the acceleration, and the derivative of the position function is the velocity. So now if we were to go over and look at this graph right here, it describes and shows a car moving over a certain period of time. It moves at a constant acceleration. And so the position graph, as shown here, it's described as an x squared function, and that's the function, and you can see that it accelerates slowly and gains more position as it increases in time, that the position slowly gets more and more increased. And if you were to take the derivative of that, a derivative of a curve function is a slanted function or line, which would then be described as 2x, as we solved for before, and that would be the velocity function, as it keeps increasing due to the acceleration. Now, a derivative of a straight or slanted line is just a flat line. And if you were to take the derivative of 2x and take the derivative of the velocity function, that will give you the acceleration function, which in turn would be 2, as if we were to take the derivative of what we solved for in the PowerPoint, we would be able to see that the derivative of 2x is 2, and that gives you just a straight constant acceleration of the car that is moving over the certain allotted time. And as you can see, these all tie in with each other and are all derivatives of each other, or derivatives of each position and velocity, and so they all tie in, and derivatives are a big tie-in to this type of lesson, and it is a big help to be able to see that the derivative is actually just the slope at a certain point, and it's recorded into each one. And there you go, that is a derivative and how it ties into physics.